created DisCoS, which stands for Distributed Control System. This is a framework to create a hive mind out of any collection of network devices. It could be anything as simple as a computer controlling the appliances and heating of a household, to anything as complex as a cluster of computers controlling a network of robots. Why do we call this a distributed system? It might seem at first to just be a regular system where everything talks to the master. The reason is because of our communications network. We don't send actions, we send directives. An example of this is if a master finds out one of its rovers is stuck in a maze, instead of sending individual commands, move forward, turn left, go right, it can send an entire program to solve a maze, which the controller will then run and talk to the platform, and the master can then rest assured that the platform will eventually be able to escape the maze. Now, how is this possible? The magic comes from a .bot programming language. It's a Turing-complete, functional, interpreted programming language we created just for the DisCoS system, and it's expressed entirely in JavaScript object notation. Furthermore, because this .bot is interpreted in a Java virtual machine, what this means is the software level will never be broken, meaning that the connection to the server and all the critical threads that keep this controller alive will never be disrupted. So bad code won't break our system, and we can also do some very cool stuff, like we can pause code on the fly, we can flash new code on the fly. So this might be solving a maze, the master can just send a stop command and add an entirely new program onto it, and it will start immediately with no reboots.
So right now we're going to run a demo where we have written a program on our compiler, that our master compiler, which compiles into a .bot package that is sent to the Android, which then further compiles it into Java, and then through a Bluetooth connection with the NXT is going to control the NXT. So now, Lingnan, please start the server, so we'll see it run. So right now it's running a very simple maze solver that we expect anyone to be able to write, basically, where the robot is just basically going forward until it sees that it's too close to a wall, and then it begins to scan to determine the best route that it should take, which is obviously then the route with the longest distance. We have some safety implementations where if it's closer than 5 centimeters, it will just go backwards. This program is very basic, and the big part of this project then is that it was written in a language that the NXT doesn't actually understand, and that we don't really need to know what language the NXT speaks actually in order for us to write the program, since our master compiler just writes very generic commands that are then compiled properly into a language that the NXT understands by just writing the proper driver for the NXT.
This is the TNT educational platform. TNT stands for TNT Not Turtle. So this platform is to teach kids how to program. This is trying to simulate the conditions on the Mars rover. So here I have the area where I can write the actual code. This is an output window, and here I can write live commands. So here I already have a predefined function, and I just want to make a square. I'm simply going to write a very quick function which will loop 4 times and finish the square. So now I want to compile the code. Here's the output, no errors, and this is the JSON object, which is actually the .bot language that is sent to the server and then compiled by the Android. So let me give you a rundown of what this means. For example, here we have the definition of the patrol function, which takes 1 argument. And here we can see the main loop, which is right there. For example, assigning 0 to x, or the while loop. So now I want to start my code. So I simply write start. As you can see, the video is updating on the rover. So now let's say I want to run a simple turn right function live. So this will turn right for 90 degrees. There we go. Now maybe I want to call the patrol function. So this would make it go forwards for 20 centimeters and then turn around and go back for 20 centimeters. There we go.